Welcome to Sekus Theory Part 2, the Big Bang. What happens on a Big Bang? What does we know? We know at the start there's something called singularity, a very high density energy unknown. And this singularity somehow changed shape, forming the universe. In common physics, they thought there are matter and antimatter annihilating itself, only leaving a very small part to form the universe. But as I show you, it has to be different. When using the energy conservation principle, it can't be that this part of the universe was all. So this is calculated as a part of the singularity that makes the matter we know. So energy conservation principle, all of the energy has to come to our universe, not only this part. So this is a part unknown in the universe. Maybe some calculations are different, 1 billionth part, but it doesn't matter, because by far the most is unknown. As you see, every scientist say we only know a very small part of the universe, and he's right. And but what is the other part? Because of the energy conservation principle, it's only the other part in the universe is the leaving part from the singularity. And now my theory starts. I generate something, I think, and this is the basic part of the universe. So I ask myself, what is the most common way to show matter? Because the universe is made of matter and energy. The most common way to a physics is to show matter as this. This is matter. Simply a core or a point, something seems to have no energy, to be massive. And how does the scientists, the physics, show energy? This is the most common way for physics to display energy. So the combination of matter and energy is the thing we know. Is that all? The singularity itself completely becomes anchor quants. This is the anchor, this is the quant. The quant is known to us because it's some particle of pure energy generating a quantum field which we can't penetrate. This quantum field is much smaller than the known atoms, because the anchor quant is used to build the atoms. And how this can be is a later part. The singularity has dropped into the universe as a ball, cloud, or something of A-quants. So the whole singularity is A-quants, and this means the number of A-quants in our universe is limited. There's no endless A-quants, limited A-quants. And the dropping of singularity to A-quants is the first expansion. After the first expansion, there comes a time of darkness. Why is there darkness? This is because after the first expansion, everything was even. All particles are the same. There are no differences. But this is part of my wave theory. And when everything is even, there are no information exchanged. No information exchange means there's no light, No sound, nothing. It is dark, it is silent. Some will tell it is perfect, I will think it's hell. And but how the hell starts lightning again and expanding again. Yeah, I think the quants moves around the core, and this causes a light form of magnetism, and the motion itself have an effect. So in some cases, with over a long time, the quants starts to synchronize. They are not balls moving everyone for itself, they start moving around each other by synchronizing. And this moving around each other's make the space moving. And the moving space has several effects, as I show you. What happens in a spinning quantum room? The centrifugal forces making the higher density quants moving to the outside. But what happens to the inside? There's nothing that can fill the gap. So to decrease density in the center, the only way for the quants is to grow. The quantums in the center of a spinning quantum room grows, while the most energetic quantums are at the outside, using all sizes of quantums when going inside. This is elemental. This is, to understand this, is the first point to understand the universe. So, with the spinning quantum space, the next part of expansion started. And the next part of lightning started. The universe gets illuminated again. The next part is about the atom, how to build an atom with A quants. Have fun, keep watching and enjoy.